Hey, what's up, guys? So today, let's solving this interesting question that I just found online. So the idea is that so the settings that we have some number xi I from 1 to n, and our assumption is that all the xi are reals, and the ci are just some also some positive number. Okay, and we want to prove the following two. Okay, so this we want to prove that summation ij, so basically I from 1 to n, j from 1 to n, this xi is greater than or equal to 0. And the second one is I from 1 to n, j from 1 to n, this xi divided by xij divided by ci plus cj is greater than or equal to 0. Okay, so you guys can think a little bit and let's go to the answer. Okay, so the first one is trivial because obviously that is xi, xj, I from 1 to n, the j from 1 to n is a separable, right? So you can write as this. Right, because that is trivial because my assumption is that each xi are greater or equal to is just a real number. Okay, so second one is an interesting thing because all you have is the following. Okay, but you don't know because the only thing we have is this ci greater than 0, 0, greater than 0. So each voice will be there will be each voice on this part. So it's not guaranteed that it's not easy to see why this guy is greater than or equal to 0. Okay, so the idea. So idea is the following. So let's consider f of x defined to be a summation of xi, xj. Let's not using x. Let's change a variable. Let's using another variable. Let's call it maybe use y. Okay, so y and ci plus cj. Okay, so obviously that this is continuous function. So this is a differentiable function on y. Okay, so if you use mean value theorem, so your f1 minus f0 equals to f prime b and b. Okay, so b belongs to open in the open interval 0 and 1. Okay, so f of 1 is just this. Just what we want to prove. And f of 0 is 0, right? So it's 0 equals to a differential respect to this. So if you respect to you get xi, xj, b, ci, cj minus 1, ij times b. Okay, so you get I, j, xi, xj, b, ci plus cj, which is summation xi, b, ci squared. Okay, and obviously this guy greater or equal to 0 because my assumption is that all ci are greater than 0. So b to the ci is always it's a power of some positive number of positive a positive number with the positive power. So it's always well defined. Okay, so by mean value theorem, this guy is greater or equal to 0. Okay, so this problem is very interesting, especially for this one. It's very non-trivial to. I mean, at the beginning, I cannot prove this guy is greater or equal to 0, but you can, if you follow this proof, then it's greater or equal to 0. It's very interesting. Okay, see you guys.